Hi, thank you for your interest in LPCXpresso. This is the second half of our Getting Started Introduction to the LPCXpresso tool and software. We assume that you have completed the first LPCXpresso Getting Started tutorial and know the basics of how to deal with the example projects. This time, we will focus more on setting up your own projects. Let's start by demonstrating how to create an empty workspace to support LPC 1114 development. If you have been following along with our previous tutorial, your LPCXpresso workspace probably looks very similar to this. The workspace is cluttered with many example projects. Since there is no Create a New Workspace or Close Workspace command in LPCXpresso, to create a fresh workspace, use the Switch Workspace command in the File menu. Browse to the location where you would like your workspace to be created. In this case, what we're going to do is to make a new folder to hold our workspace. We're going to call it LPC 1114 _ getting started. Now click OK. And then click OK again. LPC is now going to close the current workspace, shut down, create a new empty workspace in the directory that we specified, then restart and open the new workspace. Although we have an empty workspace, we are still not ready to begin development. Most Cortex-based code projects will use the industry standard Simsys header files, so the Simsys project must be added to the empty workspace. To do this, let's use Import Example Projects and import the Simsys headers from the LPCXpresso Examples directory. Notice that we have selected the Simsys v1p30 _ LPC11xx.zip project. This is inside the LPC11xx directory in the examples folder. Now click Next and then Finish. Alright, the Simsys package has now been added to our new workspace. Let's make our own project so that we can start writing code. To make this process as simple as possible, a new project wizard is supplied in LPCXpresso. To start the wizard, expand the Project and File Wizards group in the Quick Start view, and then select MCU Project Wizards. A menu will appear with a list of NXP LPC microcontroller families. We are going to create an LPC 1114 project, so we will select the LPC 1100 project. LPC 1100 family. Now click Create NXP LPC 1100 project. Type in the project name, in this case, Demo, and click Next. This panel gives you the option to select if you would like to use the Simsys library or not. Simsys is a standard created by ARM to harmonize the chip header files between multiple compiler vendors and microcontroller manufacturers. Generally, it makes sense to always check Use Simsys. This checkbox causes the project wizard to add an include search path and a library path which link to the Simsys project that we imported earlier. Now select Next. You are given the option to change the name of the source code directory and also to input an author and copyright. Now click Next again. The build targets are displayed. Normally, a debug and a release target will be created. The debug target will be set up with compiler flags preventing automatic code optimization. The release target will enable some optimization, which will save flash memory, but it could make debugging less intuitive. This Select Configuration section of the new project wizard also shows an Advanced Settings button. This is where you can set many project-specific settings such as compiler flags and include directories. We will not use this feature right now, but we will be seeing this dialog and making changes later in the tutorial. Click Next, and then select the processor part number. This is necessary because although we selected the chip family when we picked the LPC 1100 wizard, we have not specified the project down to a specific part. A specific part is required so that the tool can create the correct linker script and fit the code into the chip's on-chip RAM and flash. We are using an LPC 1114. There were unreleased variants of the 1114, so we will choose the 1114/301, which is the shipping product. Luckily, this is the default when creating an LPC 1100 project. Click Finish and an empty project will be created. Now build it to make sure that it's okay. Notice that first the Simsys library is built, and then it moves on to build the actual demo project. If we check out the Problems view, we will find that there are 0 errors or warnings, which is exactly what we would want. If you explore the wizard-created project, you will find that it has no functionality. Inside main.c, we will find nothing more than a while-1 loop that increments a counter. We would like to add our own code to the project. It turns out there are many ways to add files to a project within LPCXpresso. Today we will show how to use the import dialog and also how to use drag and drop. To use the import dialog, right-click on the node where you would like to add files and choose Import from the context menu. Open the general node in the tree and select File System. This is what you would do if you want to copy a file from somewhere else on your hard drive, or you could select Archive File instead if you have a zip, gzip, or tar file, or a jar file. We're going to copy files from the hard disk, so we are selecting File System. Now click Next. Use the Browse button to find the directory where the files are. In this case, they're on the desktop. Click OK. Now LPCXpresso will display a list of all of the files at that path in that directory. Using the individual checkboxes or the Select All button, choose which files will be included in the project. We are just going to import adc_main.c for right now. If we go to our Project Explorer view, we can now see that ADC_main has been added to the project. The original file will remain unmodified. This is a copy. Another way to add files to an LPCXpresso project is to use drag and drop. Select the files in a Windows Explorer window and drag them onto the project node. They will be copied into the project. In this case, we're also going to add the readme.txt. You can add files to a project other than .c and .h files. They will show up in LPCXpresso and can be easily viewed. This is the readme.txt file that we just added. Okay, let's build our project and see if it works. Unfortunately, our build failed. It looks like we have a problem. Let's go to the Problems view and see what it might be. It looks like we have multiple main routines. One of them is in ADC main.c, and the other one is in main.c. This happened because the project wizard created a main function in main.c, and we added our own code which already has a main function. To take care of this, you can right-click on main.c and either delete it or choose Exclude from Build. If you delete it in LPCXpresso, it will be deleted off of the disk, not just out of the project. So we will exclude it from the build. When you choose Exclude from Build, you have to select which configurations it will be excluded from. You could have it built into a debug configuration, but not into a release configuration. This could be good if you have some debugging code such as printf or something like that that takes up a lot of flash space that you don't need in the shipping product. In this case, we will exclude it from both configurations because if it's included, the project will not build at all. Alright, let's build. It looks like all of our problems have been solved. Project operations. It is time to go over a number of basic project operations. Creating a file from scratch. This can be done by selecting a node in the project and then selecting File, New, Other, and drilling down the tree to pick the type of file you'd like. There are templates for many file types. If a C source file is selected, LPCXpresso will ask for a file name and create a file with a comment block. Also, you are able to use the right mouse context menu instead of the file menu. When the files are created, they will automatically be added into the project underneath the node that you selected when you created the file. Now let's create some directories or groups in the project. After creating this project, I decided that I would like to clean up the organization a little bit. Notice that we have a group called source, well, SRC, that has .c and .h files in it. I would like to create a group called INC to hold the .h files. To create this group, right-click and select New Folder. We will call the new folder Inc. In LPCXpresso, when you create a new folder, it actually is mapped to a specific directory on the disk. I will now move adc.h from the source folder into the Inc folder. That was pretty easy. By popping up an Explorer window, we can see that the file has actually moved. This is our project directory. Notice I used a shortcut to pop up the Explorer window, which is just to click on the project name. We now have a source directory and an Inc directory. Inside the Inc directory, here is our file adc.h that we just dragged. Alright, let's build the project and see how it goes. Oh no, that is not good. It looks like I broke the build. There are many undeclared items. Wait a minute, it looks like the include file adc.h was not found. This is because the compiler will typically only find included files in the same directory as the .c files. Because the file grouping in LPCXpresso is actually a different directory and not just a group, when we moved the file into the Inc folder, it moved it out of the directory with all of the other .c code. To fix this, we will have to add the Inc directory into the compiler include directory search path. It is time to move on to our next section, Editing Project Settings. Editing Project Settings. To edit the project settings, right-click on the project and select Properties. The tree control on the left selects different property panels. The first one we will look at is Project References. Project References specifies dependencies between projects in the workspace. Our workspace has two projects, Demo and Semsys v1p30 underscore LPC 11XX. The demo project is currently active and is not displayed in the Project References dialog. We are editing the demo project's properties. In Project Reference, the Semsys project is checked. This means that whenever the IDE needs to rebuild demo, it will first make sure that Semsys is up to date. If a project generates a library, the other projects in the workspace using that library should have the library generating project checked in Project References. This is exactly what you see here. The Semsys project generates a Semsys library, and the demo project uses that library, so the Semsys project is checked as one of the demo project's references. Now we will go to the C/C++ build section in the project properties. MCU settings is a place where you can change the part number of the microcontroller you are using. Typically, after a project development cycle is complete, it is discovered that a lower cost, pin-compatible variant of the microcontroller on the demo board can be used. In MCU settings, you may choose a part with less memory, like the LPC 1112. In this case, we're going to continue to use the 1114. Now we will go to the Settings group under the C/C++ build. This is one of the most option-packed places to go for project settings. It brings up another tree view with settings for the compiler, the assembler, and the linker. Under Symbols, under the compiler, you can define macros that you can test in poundif and poundifdef statements in your C code. For instance, this one, __code_red, allows your code to check whether it's being compiled in LPCXpresso or the Red Suite development tool. Under Directories, you can add an additional include path. Notice that we have an include path set up to the Census Library Projects Inc. directory. This is added by the project wizard when the new project is created. Let's add another include path for the Inc. directory that we added to the demo project. Before doing that, it is a good idea to check the current configuration and make sure that we are going to be changing all configurations and not just the active debug configuration. If this is not done, then when the configuration is changed to release, the build may fail. Alright, let's click the plus sign to add the path. We will use the Workspace Browse button, which will create a workspace relative path, rather than using the File System button, which could create an absolute path. Alright, we have added our Inc. folder into the path. This should fix the compile errors we had caused by moving the adc.h file. Alright, moving on to other panels. In optimization, the compiler optimization level can be set. The underlying compiler used in LPCXpresso is GCC. There are many more optimization settings than are available in this drop-down box. Additional flags can be specified in the Other Optimization Flags box. For information on the optimization flags, check out the Getting Started guide. Moving down to the MCU linker group of build settings, Libraries allows you to add libraries to your project. This is a good place to be careful. Library search paths are typically different between the debug and release configurations. Using the All Configurations choice is not recommended when making changes. Okay, remember in our last section, creating directories or groups in a project, we moved our adc.h header file into an Inc. directory and broke the build. Since we just added an include path, this should be fixed. Let's quit the Project Properties dialog, build the project, and see if we have fixed the problem. As you can see, the build was successful and our errors and warnings have gone away. Modifying linker scripts. One thing that comes up from time to time in embedded development is a need to modify the memory map used by the linker. LPCXpresso generates linker scripts on the fly depending on which libraries you are bundling into the program, the build configuration, and the microcontroller part number you have selected. Our first step will be to copy the generated linker scripts and modify them. Let's pop up a Windows Explorer window and take a look. Here in the debug directory, we can see the LPCXpresso build output. The linker scripts end in .ld. Let's copy them, make a new folder in our project, a new folder called LD, and then paste them. For this demo project, I am going to modify the chip memory map in the linker script to leave some empty space at the beginning of RAM. This could be useful if we were using the LPC 1343, which has a USB port and a ROM USB driver. The built-in USB driver requires 304 bytes of RAM between hex 50 and hex 180. In this case, since we are using the LPC 1114, which does not have USB, this kind of technique could be useful in case you need to do something advanced, such as generating code to go into a partially pre-programmed microcontroller with code or libraries already in Flash, or it could be useful to implement code read protect, which requires putting a specific value at a specific location in Flash and then keeping the compiler from placing anything else there. Let me rename the linker scripts so we don't get them confused with the generated ones. I am calling them demo180_mem.ld, demo180_lib.ld, and demo180.ld. Let's take a look at these linker scripts in LPCXpresso. Our LD directory has not appeared in LPCXpresso yet, but if we go to the project, right-click, and choose Refresh, then it will be added. Opening up demo180.ld, we can see that it has two include statements to link to the other two linker scripts. The only problem is these statements still contain the file names of the generated linker scripts and not the file names of the ones that we are going to edit. Let's update these file names to point to our copies. Since LPCXpresso's linker is running out of the debug or the release build directory, we need to add a relative path to reference these other scripts. We will put .. // which causes it to go up one directory in the directory hierarchy. Alright, now let's open demo180_mem. This is the script that we will use to change the RAM region. Notice that RAM is at 10 million hex, and it is 2000 hex bytes long, or 8K. We're going to change the RAM to start at 10,180,000. And then we must also change the length to make sure that the linker does not place any data beyond the end of RAM. We would change the length to 2000 minus 180, or 1E80. Finally, now that we've changed these linker scripts, to get LPCXpresso to use them, we will have to go back to the Project Properties dialog. Select Settings under C and C++ Build, and then pick Target under MCU Linker. First, we uncheck this box, Manage Linker Script. This will stop LPCXpresso from regenerating new linker scripts. Now we need to change the linker script path so that LPCXpresso's linker will use the linker script that we just modified. Now we're going to exit the project settings and build our project to make sure that nothing is amiss. Okay, looks good. We have a successful build. To make sure that we have RAM below 180 free, open up the linker map file. The map file is in the debug output folder. Right-click and choose Open in Text Editor. In a section titled Memory Configuration, we can see that our memory map changes were accepted. RAM now starts at hex 10,180,000, and the length has also changed. Moving down to the .data section, we can see that the linker started to map data into RAM at hex 10,180,000. There is nothing mapped in RAM before there. It looks like we have succeeded in leaving the memory free. Let's test to see if our program still runs. Alright, we are in main. Let's click Go. Looks like we have a success. Despite moving our program's RAM allocation, it still runs fine. Creating binary output. The LPCXpresso tool defaults to generating a .axf output file format, but it can also generate a pure binary file. To generate a .bin file, navigate to the .axf file inside the build directory, right-click, and choose Create Binary under the Binary Utilities menu. This binary file is useful for use with bootloaders and flash programming tools such as FlashMagic. Sometimes you may need to add a vector checksum into the binary file. This is most generally useful when you are using the USB mass storage device bootloader that is in the LPC 1343. LPCXpresso includes a tool which will allow you to do this. This is a command line tool. To access the command line easily, hold down the Control key and click on the project name in the lower right window border of LPCXpresso. Now we will move into the compiler output directory. You can see that our bin file is right here. Now we will run the checksum utility that is included with LPCXpresso. As you can see, the file has been updated. It now includes the new checksum. Thank you very much for taking the time to listen to the second installment of the LPCXpresso Development Platform tutorial. If you have any other questions, please visit our technical support forum at www.nxp.com/lpcexpresso-forum and our support and FAQ page at www.nxp.com/lpcexpresso-support.